Hello Earth, welcome to episode 35 of season 2 of Making Cell, a series of videos where I record myself designing and implementing a programming environment called Cell. So if you're just tuning in for the first time, please check out the project at github.com/autocodon/cell, link in the description. We are implementing sequence, which is basically a call that does multiple things. In other programming languages, this is usually called a function or procedure. So we were really in the thick of it yesterday. We wrote a test that we're not passing, this one, and yeah, so we're calling cell do with the define and the execute here. I don't know what's going on. I almost feel like I have a writer's block. It's not that I'm blocked, it's like I just don't want to do it. I want to do something else. That's less demanding mentally. I don't know. I'll try not to make a big deal out of it and push. I don't know why. I should be really excited about this. Who knows? It's a pretty mysterious process, honestly, this thing. So we need one on define and one on execute. So we can do the define one. That shouldn't be too hard, right? If it's define, it just passed the path to the whole thing. Wait. I have the add do. Do I really need a context path there? Nah, I don't. Do I? No, because I'm defining. The definitions. Oh, this is tricky. When I'm defining something, when I'm doing with the put, the put is in charge of doing that, right? Having the context. Yeah. 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 So when I'm getting this thing, honestly, I should not need some Mitch murder. Always great. So I'm really XXXYY, call it whatever you want. Let me just put a debug. It's like I need to see data in front of me, otherwise my brain is not firing. Okay, +1. So I need to get plus. I'm getting impatient here with myself. Plus, yeah, I need plus at do, +1 at do. I don't need a context path. I need an absolute prefix to give me the actual definition. We need the context path when we know where, but if we're looking at one of these, we already know where. The definition is in situ. It was done with the put and now we're getting. So we do not care. We do not care about the context. We'll put that in the annotated source code. We don't need any of this, but I guess you need the get. Almost really. This passing around of the get and the put is pretty silly too, I think. Okay, one thing at a time. Let's just try not to kick the chessboard. if possible. So we just do something like this. What? There. Debug, define. Okay, I'm getting this. Yeah, I'm getting that mess. But at least in that mess I can find answers. That's good. Well, when I'm defining, I need to validate, right? Yes, of course, I have to validate. I don't get enough of this trick. I can't get enough of this trick. Just call it definition. Query path. Definition. If type of JS definition is not an object, I almost said hash, return error. I want present in call. No name present. No. A sequence must. The definition of a sequence must contain a name for its message. But instead, we get. No, actually, we don't have to say what it is. It's just fine. Because it's in situ. It's so glorious to have that in place. If the keys of JS definition, if the keys are not, wait, it's going to be a name, right? Must know. They contain a single name for its message. And then we can just take the second level, right? Which would be I just need them to be consecutive, that's it. So if I need to check them to be consecutive, 1, 2, 3, 4, 5, I need to check that the first one is 1 and that the last one is the first one plus the length. It would be JS definition. We'll need to have a calls that allow us to do this with ease in cell, but that's after we already have sequences, right? So JS definition, these are the values. If steps. But it's going to give me perhaps a sparse array, and I don't want any of that stuff. No, I just need to look at it as data, really. I will just go to the paths. I guess I can do it as operations of path. So I'm just changing my mind about how to do the validation. Not fully, just partly. So for example, if definition, there has to be something, right? Otherwise there would be nothing there. There could be nothing actually. That's a good one. Oh, Mitch, what a record, huh? A message. Message name, and at least one step. The definition. This is not a string. Then we do this. Yeah. And we will check the hash check there. Sorry, not the hash check, the single. We get rid of this. And then we have we can do the iteration now of the definition. Steps one, so not steps one, path one. Doesn't include path one. They're gonna be sorted because it's for data, right? So we can do it like this. If steps 0 is not 1, the definition of a sequence must start with step number 1. Easy enough. And then if is not equal to, I cannot know that. I will have to do it with JavaScript. I can do it here. I can do it here first. Definition 0, 0, no, 0, 1. And what I can do here is something like this. Stop node. Basically, I need to look for a jump of more than 2. More than 1, sorry. And define if path k minus 1 and so paths the definition and definition k minus 1 1. Actually, let's do it like this. Path 1 minus 1 is still greater than the previous one. We're gonna do it here. The definition of a sequence cannot have non-consecutive steps. No sparse arrays. And now what do we return? We return this is gonna be good. We return a hash where the first element is definition 0 0 and the last one is Teishi last definition 1 because that's the number of steps. That's nice. That's pretty. I like it. Boom. Yes. Oh, come on. What do you mean it's not a function? That's just nonsense. Sorry, but it's nonsense. I would never. Of course. Capital S. Okay, so let's just do a look. Look, it worked. No, sorry, that's the expected. It worked. No, I'm not sure if it worked. Okay, just give me a minute. I'll be right back. All right, I'm back. So where were we? Yeah, I was trying to figure out if this was correct. Bum, 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 bum. Bum, 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 bum. This looks very correct. So y plus... Oh yeah, it's correct. It worked. Look at that. Y 2. Is it 2 or 1? I forget. Keep on forgetting. What was my example? It's only one step, really. Where is this coming from? This is their actual definition. Am I just going crazy here? just int1. That's it. No, this is wrong. Because I cannot assume that the thing knows that. I have to be explicit here, right? I do. Okay, I think that did it. Yes, okay, that was a subtle bug. Have to clarify it. Otherwise, the thing cell need thinks that if I put a dot, it's just something else. It's the next one. My bad. Okay, okay, the test was wrong. Okay, that's good. We support definitions now, don't we? Yeah. Yeah, this and this are the same. I need to basically freeze all the other stuff, really, right? I do. Because I don't want all those intermediate results, really. You know, I'm tired a bit sometimes of this, of looking at just JavaScript paths. I'm really missing for data. Well, that doesn't help me that much, right? It would be +1. So I can do this. My bad. Okay. Okay, 11 +1, 10. Yeah, this equals. I have to get rid of completely. The do basically freezes everything. So how do I know that it's a frozen thingy? Yeah, because we need to get rid of the noise. Let's just change the music a little bit. What was it? Let's go with this one. Only 22 minutes. It's part 1. Yeah. Yeah, that's what we have. 22 minutes. Sounds about right. How do I know that whatever is after this should be frozen when you're on that path, right? I think you can do it like this. If between the context path and the rightmost at can do it like this. I did this somewhere, I think, indirectly. When I was doing the parser, like just going through it, and it was, I think, the cleverest piece of code I wrote. Yeah, I did it somewhere. I find it alarming that alarming that I remember a little bit, but then the rest is just lost. There's what's it with the indentations? I did like I had a loop that then remembered only what it had to remember and then forget. I think it was in the decoder, right? Well, it was not called the decoder, the unescaper. Maybe it was in a previous version of the unescaper. Yeah, it was a previous version of the unescaper that was trying to be clever. And then I just went with double slashes in. Yeah, I didn't have any need for that. Okay, well, that just reminded me of that. So we would go through the path entirely, because honestly, if k is greater than 0 and v is a path, k minus 1 is an add, and I can only freeze this stuff if it's not the end of the path. Can I have nested definitions in the same path? I'm laughing outside, but I'm crying inside. Yes, you can. Of course you can. Yeah, fun. Why would you do that? Yeah, I guess there would be a very good use case for that. So how do I know how to freeze them? If I can have something like this, right? No, wait. It is frozen. It has to be frozen. This will only get executed when this is referenced, called. A reference and a call are the same. When I say things like that, sometimes I think I feel like Michael from The Office. Yeah. So yeah, it's frozen. It's fine. If it's not the rightmost, uh, so here there's an undo. Yeah, and the value path. So what are those other paths that should not be expanded? Show me, show me. Yeah, that one. They don't have undo, they have just add. If there's an undo before you in the middle, don't do anything. So would be give me if k is greater than 0 and query path k minus 1 equals do, no, add, and step equals do frozen is true. Can do it like this. Return true. Beauty. If frozen, return, don't do anything. Okay. I want to believe we fixed it, although we didn't. I am not happy with this console log here. Let's just add some color. Oof, even worse. What was I thinking? Yeah, also not that good either. Oof, horrible. Let's try to read this instead. Plus add. Yeah. It's still expanding them, right? Yeah. Stop on true, dude. Come on. Yes. That's it, right? Yeah. Okay. Alright. Oh wait, now I lost it. I lost this one. Um, why is it? But why if it's the rightmost at? I guess I have to do it. I'm ignoring the rightmost path. It's everything to the. It's everything but that one, exactly. Yeah, the thing is, I don't know which one's the first one, so I cannot just nix it because of that. How do I know which one's the first? Oh, indeed. Because what I'm expecting is +1, so it doesn't have to be on the left. So it's the first add do. I need to find the first add do. and only do that first add do. That's it. So the logic is completely different. It's almost no, it's not. It's not almost. The logic is left to right. The do to the right is frozen. How do we know which one to expand into equal int 1? It's the leftmost do on the path. We need to check that we are at the head of it. So if the leftmost one is an do, leftmost add is an do, then we do the same trick that we do for the if, right? Do we do that for the if? I thought we did. No, for the if I think we just run it every single time. Yeah. If I just do the leftmost, actually it's fine. I actually don't have to get the first one. I can just run it n times. And not have to check the head of it. Just do it on every single one. Yeah. Inefficiency has taken us a long way. What is it? So you check that the leftmost is okay, I'm starting to like this a little bit. This should not be called query path, it should be called target path, really. That annotated source code is gonna have to change quite a bit. Yeah. Okay, we have that. Okay, I'll be right back. Okay, I'm back. So, where were we? Yeah, so we were checking whether we are doing the expansion right for plus, right? Which we are. No, we are not, because now we froze everything. Yeah, so the idea was to basically do things only for the leftmost do on the path, not more than that, exactly. So this would be like this. guess you could do it like this. If leftmost at is equal to the rightmost at, sorry, it's not equal. Because if they're equal, you want to expand it, right? No, not really. Let's look at the target, right? Again. So basically I want, yeah, this actually is helpful, just looking at the data. So we have this, so we're going to start with the rightmost here. But I want to ignore this one and ignore this one. Why do I want to ignore them? Because there's an add-do to the right. So I am only in the business of expanding this one. Really, that's it. That's all I need. Yeah, so basically I need to change the logic so that if I just look at one of these, it has an add do, I guess without equal, right? Because this would get resolved to an add do, right? Add do. Maybe not, it would be an add do, it would just be the, well, yes, it would be. I'm trying to distinguish between this one and this one. So let me just go to 34. And let's start with the easy one, +1. Ignore any adds that have do to its left. This one, if I just do it again, but to an equal, it's fine. It's inefficient, but it's okay. Just process the leftmost add do. So what we can do here is the following. Honestly, we don't need that leftmost. I guess it's nice to put it like that. It's a bit more clear. Never mind. So now what we would consider the target path to be the rightmost at. Not really, it would be the rightmost at that is has no add do to its left. If not, the rightmost at is this. So let's just make it data. That's why I'm going so slow, because I'm not making it into data. So then when seeing then the context path is +1. Really. Context path is +1. Then the target path would be +1 equal, which is everything to the left of the, well, not the rightmost at, it would be this one. If we consider this to be the rightmost at, then that's the target path. Yeah, perfect. And then the value path would be this. It would be it would be do, because we're removing the at, right? It would be do int. So that one. It's basically how does the value path get an equal? That's where you're getting it from. So in this case, yeah, in this case it almost feels completely wrong, because I really don't want to do that at all. In this case, the value path is something else completely. The value path should be +1 equal. No, well, that's silly. Sorry, the value in that case is not given by value path at all. So value path is completely ignored. And look at this, it's pretty interesting. Value path is ignored here and here. So that's actually okay. So in this case, what we need to do is we need to shift we can do this. If k is plus more than 0 and path k minus 1 is at, and path, sorry, it would be v equals do, rightmost at is going to be k minus 1. Actually, why do we have to do it like this? We could do it forward. But here we need to prevent so let me just do something here. Sorry, yeah. So now what I need to do is yeah, I get basically the value, and the value is not undefined, so this will stop it. So the leftmost one will be set here, and the rightmost one. So we don't need to do anything with the frozen here. Okay. So we're starting to get there, I think. So it should not be k minus 1, it should be k. Wow, it worked. That was the bug. Okay, this is working now. Yeah, that's good. We don't care about the context. Okay, we have one part of it. Now onto the other. So the working value is it correct? We int 1 at, yeah, it looks very correct. The working value is correct. Actually, the working value is fine. And this one we do care about the context path, right? We definitely care about the context path, or not? Yeah, we do. Let's pass it. I find it interesting that we don't care about the context there. Ah, yeah, because we're not executing anything. I just need the working value, the context, and the ridiculousness of doing the get there. I guess I could just could pass the definition, right? Let's remove the get from there. The context path, I mean, whatever, let's just send it to be uniform. I won't say consistent. You can just do definition like this. Instead of walking variable with the definition. Okay, we have this. This definition. Okay, we just broke everything and then fixed everything except what we're doing. Perfect. And now it's not ignoring anymore this foo here. Okay, lo and behold, we're getting the same definition 3 times. Perfect. That's exactly what I was expecting, or I should have expected. So now we're in a position to do something about this. I think we can do this in both, right? Yes. message name would be so I guess I will have to start with this. So colon, and then a message name would be definition 0, would be cell get would be definition 0, sorry, 0 context path. No, this is just wrong. It's not that. I need to pass not the definition here. This would be yeah. Yeah. Yeah, minus k, right? We'll call it a call. It's the path. No, it's a literal unless it has a not. So we just put it as such, right? And if it has to expand, let's see. It'll be 0, 0, 0. Wow. Definition or actually this is a bit annoying. It should be empty. Yeah. So what is going on here? The definition is just fine. What about the message? The message is 10, which is perfectly fine. Yeah, why is this an array? Because I need to splice it in there. Yeah, that should do it. All right, we're starting to get there. No, it should not be in the equal. It should be in the colon. That's an issue already. In this case, we need to shave the equal. TargetPath. TargetPath slash 0 minus 1. Yeah. Okay, we're starting to get there. All right. Okay. So our next step is going through the steps. Well, we already did this actually. We need to read the validations and then take the steps one at a time and get the results. The stops, the equal, put the expansion. Okay, and this one is going to be even a bit trickier. I think we'll stop for now and we'll keep on going the next session. Thank you for watching.